Hi, it's Fazana again. Welcome to another video on Fazmaths. Today we're going to look at solving algebraic quadratic equations. Before you continue watching this video, please make sure you've watched my other two videos on factorizing quadratics. One with just 1x squared and the other one with more than 1x squared. And the one with more than 1x squared uses the AC method. So please make sure that you're really comfortable with that method. Some of these questions can look pretty overwhelming, and as long as you can identify them as a simpler format, you'll be tackling them with ease. Let me show you how. In a few of my videos, I've mentioned that both linear and quadratic equations take one of these formats. So either it's 3 equals 6 divided by 2, so you multiply 3 times 2 equals 6, or it will look like 3 over 6 equals 2 over 4, so you cross multiply 3 times 4 is 6 times 2. So in both cases you're getting rid of the denominator. Or it'll take fraction form. So if you've got a fraction plus a fraction equals a fraction, then you can tell that you're just doing the same method as adding fractions. So you're using the lowest common denominator or a common denominator. Or it will look like a fraction plus a fraction equals 1. And then how to deal with that. Or it will look like a fraction plus a fraction is a number more than 1. And we look at how to deal with that. Okay, let's take an example. Okay, so if you've got this question here in your exams, then when you look at it, a smile appears on your face and you think, oh, this looks like 6 divided by 2 equals 3. So I will cross multiply. So I've got 5, 2x plus 1 equals 3x times 4x plus 7. And let's expand. So we've got 10x plus 5 equals 12x squared plus 21x. Okay, we know with all quadratic equations, apart from completing the square, we make one side 0. So because the x squared is on that side, we're going to make this side 0. So we're going to minus 10x and we're going to minus 5. So we've got 12x squared, and then 21 minus 10 is 11. So we've got 11x, and then we've got minus 5. And because it's more than 1x squared, we're using the AC method. So A is 12, B is 11, C is minus 5. And when you multiply A times C, you get minus 60. So you're looking for two numbers that add to give 11, multiply to give minus 60, and because the sign when you multiply is a negative, you know one's a positive and one's a negative. So you're looking for factors of 60 that have a difference of 11, and you get 15 and 4. And remember, the sign of the bigger number rules, so because they add to give 11, the bigger number must be the positive. And then you rewrite, split, and factorize. So I'll show you how that works. So I've got 12x squared, and I'm going to write the 4x minus 4x first, because I'll show you when we split and factorize, the 12 and 4 have something in common. And then I've got plus 15x minus 5, and the 15 and the 5 have something in common. And then you split and then you factorize. So you've got 4x, 3x minus 1 plus 5, and then you've got 3x minus 1. Those two have to be the same, and then it ends up being double brackets and 3x minus 1. And then we make that 0. Okay, and then you have to find out what x is. 4x plus 5 is 0, so you just work it out on the side, and then we'll minus 5, so 4x equals minus 5, divide by 4, and you get x equals minus 5 over 4, which is minus 1¼ So x equals minus 1¼ or, and you can tell when I'm saying an expression equals 0, I always take that number to the other side, so it'll change sign. So I can just put 3x equals 1, and then divide by 3, so x equals, oh, that didn't look like an x, equals 1/3. Okay, or x equals 1/3. Okay, that still didn't look like 1/3. Okay, and that was quite easy, wasn't it? Yeah. So can you see, although it looks so ugly, we just get rid of the denominator by following the format. Let's do another example with the same format. Okay, you've got that there. So again, it looks very much like 6 divided by 2 equals 3. So we're just going to cross multiply, and I will just expand while I'm writing it. So I've got 2x squared minus 6x equals 56. I know I want to make one side 0, so I'll do that, and then I'll minus the 56. So I've got 2x squared minus 6x minus 56 equals 0. And before I think about the AC method, I know that all the numbers can go into 2. So if I go 2x squared minus 3x minus 28 equals 0. As long as this expression is 0, then 0 times whatever will be 0. So I'm just solving that bit. And I'm looking for two numbers that add to give minus 3, multiply to give minus 28. I know one's a positive, one's a negative, because it multiplies to give a negative. And then I've got minus 7 and plus 4. Again, the sign of the bigger number rules. So then I don't need to worry about this 2 because I'm just solving it. If you need to factorize it, you have to include it with the double bracket. So here I just have x plus 4, x minus 7 equals 0, and one of these has to be 0. So x equals minus 4 or x equals 7. Okay, this time let's just test x equals 7. So you can see that would be 49 minus 21. So 49 minus 21 is 28. So 2 times 28 is 56. And then 56 divided by 7 equals 8. And you tick and you say, God, I'm good. I've said that so much in my previous videos, and I always say it once I've checked it. Okay, let's try a couple of examples with the second format, which looks like 3/6 equals 2/4, so they're just equivalent fractions, both being a half. And here I can do 6 times 2 equals 3 times 4. So I'm actually going x times 3x minus 7 equals 20. And when I expand this, I get 3x squared minus 7x equals 20. I want to make this side 0, so I'm going to minus the 20. So I've got 3x squared minus 7x minus 20 equals 0. And again, because it's more than one x, I'm going to do the AC, so A, B, C. 3 times minus 20 is minus 60. Two numbers that add to give minus 7, multiply to give minus 60, positive and negative. Factors of 60 that have a difference of 7. So I've got minus 12 and 5. The sign of the bigger number rules. So again, we're going to rewrite, split, and factorize. So I'm going to put the 3x squared with my 12, so minus 12x, because they have something in common. And then plus your 5x minus 20, split, factorize, and you've got 3x, x minus 4, and then you've got plus 5x minus 4. Again, those two have to be the same, and we've got 3x plus 5, x minus 4 equals 0. So that one is easy, x equals 4, and that one you'd actually take on that side and you say, okay, so 3x equals minus 5, because we've taken the number to the other side, divide by 3, and x equals minus 5 over 3 equals minus 1 and 2/3. Anytime you find that x isn't becoming a whole number, put it in fraction form, because it'll be easy to simplify, convert it into a mixed fraction, and you don't have to convert it into decimals, just leave them as the way they come out, unless you're told otherwise, because it's just so much easier. Okay, so I hope that was getting a little bit easier. Okay, let's try another one in this format. So again, this looks like 3/6 equals 2/4, and we're just going to cross multiply. So you've got x times 2x plus 3 equals 10 times 2, which is 20. And expanding, you've got 2x squared plus 3x equals 20, minus the 20 to make that side 0, and you've got 2x squared plus 3x minus 20. And it's a shame that they can't all be divided by 2. So again, we do our AC, so we're getting really good practice with our AC method. And you've got AC equals minus 40, two numbers that add to give 3, multiply to give minus 40, positive and negative. Factors of 40 that have a difference of 3, and the bigger number is 8, and the minus number is 5, because they add to give a positive 3. Okay, this time I'm going to leave my 2 with the 8 minus 5x. So you can see you've sort of rewritten that as 8x minus 5x minus 20 equals 0. Split and factorize, so you've got 2x, x plus 4. Oh, I keep having this x plus 4, x minus 4, minus 5 times x plus 4. It's x plus 4 because minus times positive would give you a negative, equals 0. And then you've got 2x minus 5, x plus 4 equals 0. So here it's quite easy to do. 2 times what is 5? So x will be 2.5. And that one's even easier. X equals minus 4. Okay, so that was all right. Okay, let's try it in fraction form. Okay, so over here, we're adding fractions, so we're thinking of common denominator, and we can't do the lowest common, but we can do the common, which means you're just multiplying both of them. and then you say, what have I multiplied x by to get that? So it'll be that. So then you're going 1 times x plus 1 is x plus 1. And then what have I multiplied x plus 1 by to get that? So it'll just be x. So x times 1 is x equals 7/12. And then you can see this looks like 3/6 equals 2/4. So we're just going to cross multiply. But I'll just add like terms here. So it's 2x plus 1. And I'll just expand that. So it'll be x squared plus x. And now I can cross multiply. So I've got 7x squared plus x equals 12 2x plus 1. So I've got 7x squared plus 7x equals 24x plus 12. Okay, again with quadratic equations, we make one side 0. So we'll minus the 24x and we'll minus the 12. So we've got 7x squared minus 17x minus 12 equals 0. Okay, so our AC method, and I know the numbers look scary, but it all works out. So 7 times minus 12 is minus 84. They add to give 17, multiply to give minus 84. You know, one's a positive, one's a negative. Now we're trying to find factors of 84 that have a difference of 17. So this time I'm actually going thinking 1 and 84, 2 and 42, 4 and 21. So I know my bigger number is the minus. So I've got 21 times 4. And then I'm going to rewrite, split and factorize. 7x squared minus 21x plus 4x minus 12, split and factorize. 7x x minus 3 plus 4 times x minus 3 equals 0. So I've got 7x plus 4 and x minus 3 equals 0. That one's easy. You've got x equals 3, and if you solve it the way I've actually taught you, you'll get x equals minus 4/7. Okay, so that was okay too. So can you see, you get ugly and you just make it pretty and manageable. Okay, let's take one where you get equals 1. Okay, so again, you've got the common denominator, which is x plus 1 times x plus 3. What do you multiply that by to get that, which would be the x plus 3? So you're going 3 times x plus 3, and then minus 2 times the x plus 1. So you can see there's that bit of cross multiplying there too, equals 1. Now at this stage, you should realize that anything divided by anything, or something divided by something, if you get 1, then you can see 5/5 would be 1, 7/7 would be 1. So that means that is actually equal to that. So that's the way to get rid of the denominator. So here I've got 3x plus 9 minus 2x minus 2 over, and here, if you've watched my video on expanding double brackets just with an x, we can actually cheat. It's going to be x squared plus, and then you add your numbers and you've got 4x, and then you multiply your numbers and you get 3. So here we'd be having x plus 7 over x squared plus 4x plus 3 equals 1. And now we use this, so that means x squared plus 4x plus 3 will be equal to x plus 7. Okay, and then we minus x minus 7 to make this side 0. So you've got x squared plus 3x minus 4. A nice 1x squared, so two numbers that add to give 3, multiply to give minus 4. So one's a positive, one's a negative, and you've got plus 4 and minus 1. So then your double brackets are x plus 4 times x minus 1 would be 0. So x equals minus 4 or x equals 1. Okay. I suggest you watch this video again, but without seeing my answers, just try and do them. So pause as soon as you've seen the question, try and do it, and then check my workings and confirm that you've done exactly what I've done here. And if you can do these questions just once more, in the exam you'll be able to see it and you'll know exactly what to do. Okay, now let's try a fraction plus a fraction equals a number. So again, we adopt the same concept. So we've got the denominator is 2x plus 1 times x plus 1. And then we've got this cross multiplying. So what did you multiply that by to get that? So you've got the x plus 1. So you've got 5 times x plus 1 plus 6 times 2x plus 1 equals 3. And the minute I look at that, I'm thinking, oh, 6 divided by 2 equals 3. Okay? Close your brackets there, and then let's expand. So you've got 5x plus 5 plus 12x plus 6 divided by, now here, try and expand it. So we'll just expand it my way. So do you remember I do 2x times x plus 1 plus 1 times x plus 1. And you get 2x squared plus 2x plus x plus 1. So you get 2x squared plus 3x plus 1. Okay? So that's what we have here. Equals 3. And then in order to apply that format, I'm going, that is equal to that times the 3. So I'll just put the 3 there, just so that, yeah, so I've just put it there so to remind me. So here I'll collect like terms. So I've got 17x plus 11 equals 6x squared plus 9x plus 3. I'll make that side 0. So I'll minus the 17x and I'll minus 11. So you get 6x squared. 9 minus 17 is minus 8x. And then 3 minus 11 is minus 8. And again, can you see they can all go into 2? So you've got 3x squared minus 4x minus 4. Okay, and now we're going to do our AC method. So A, B, C. So A times C is minus 12. Two numbers that add to give minus 4, multiply to give minus 12, a positive and a negative, and you've got minus 6 and 2. So let's rewrite. So we've got 3x squared minus 6x plus 2x minus 4. Split and factorize. So you've got 3x, x minus 2 plus 2x minus 2 equals 0. So your double brackets are 3x plus 2 and x minus 2 equals 0. Okay, over here, again, you'd go 3x equals minus 2, and then divide by 3, and you'd get x equals minus 2/3, or here you'd get x equals 2. Okay, I hope these examples were really useful to do, and as I said, just try do them one more time, and you'll find that it'll just make it so much easier. Okay, that's all for now. I hope the algebra formats really help with knowing how to play with the question and solve it with rhythm, and enjoy it in the process. I think the reason I love math so much is I was taught the subject in a very boring way. You had to concentrate on the numbers so much that the whole subject was so tedious. And then the letters came, and I asked the question, what do I do with these? So I developed steps in my calculations, made the letters numbers, and then treated them the same way. The same respect, same love. In part 2, we look at simplifying algebraic quadratic expressions. I look forward to seeing you then. And remember, you're in control. Keep working hard. It's so worth it. Until next time, bye.